Okay. Um, Hello, everyone. Can everyone listen to me? Okay. I guess I will start this DSC30 discussion with once again self introduction. For those of you who is here, you know me. My name is Scott, and I'm a tutor for DSC30s. And for those of you who are if this is for your first time attending discussion sessions, once again, my name is Scott, and I'm majoring in DSC and cognitive science. So if you have any questions, feel free to send me an email, and I will answer it. Anything. For example, if you have any question regarding majors and course and machine learning, yeah, anything. So here's the DSC30 practice problem set 2. You probably noticed that we changed the naming of this to practice problem set, because we don't want you to be confused with there's another worksheet which is mandatory, and this is optional. So we changed the naming of this to the practice problem set. So this PDF is available in Piazza right now. Feel free to download it and work it together as I walk through it. So this practice set will cover basic compilation, main method, and JUnit file in Java. We will also have an IntelliJ debugger demo at the end of the discussion. So as you doing the PA1 already, you might have already realized that Java cannot be run with one click. You have to be compiled and have some main method in it. So if you wish to learn more about the compilation, I have a link for here for more detailed explanation of how compilation works. And if you want to compile manually, there's a terminal, and there's some command that you could use. So do all of you know what terminal is? Okay, so here. So if you go to the all of your, I'm using the Mac. If you press terminal, there's one looking like that will prompt up. And I guess you have been using terminal for a lot of things, like for GitHub. And yeah, so if you're using a Mac, we are going to use terminal. If you're using a Windows laptop or Windows operating system, it will be called bash, git bash. So yeah, if you're using a Windows, just when I say terminal, just think about git bash. Give me 1 second. So as you might wondering, there's a terminal that belong to a certain directory. So if I do terminal here, you said there is curly signs here, which means that I'm in the root directories. So I need to cd change directory to my current working directory. So for those of you who are using a Mac right now, I'm going to teach you one trick. So for example, if you're going to have, there's one project. This is in your folders. Right-click it. All the way down here, there's an option that says New Terminal Add Folder. So if you click that, there's a terminal initially instantiated in that folder, so you don't have to go through all your directories. Yeah. And so in the terminal, with the folder that contains some code Java, execute the following command terminal java c, some code.java. C stands for compilations. So this step is also known as the compilation step. It changed the .java file into a .class file. So for demo, cdsrc. So it's java c d1 demo.java. Okay, I'm sorry, I haven't installed Java yet. Okay, you should, after running this, you should see the class proper now here. The M1 Mac messed up everything, sorry. And then subsequently, a binary file is created called sumcode.class. And executing the following command in the terminal will run the main method of the class. Okay, here's the first question. Which file will be, which files does the following terminal command Java C sumcode 1 Java, sumcode 2 Java compile? Is it both compiling or the first one? To be honest, I don't know. Larry, could you help me to test on that? Java C2 Java file. Sorry, my Java is not working on my computer, so. Yeah. I'll figure it out after this. I will make a PR suppose. Sorry. And the second one is the Java sumcode will run which part of method Java first? Which part? Yeah, it will initiate the main method first, and the other method will be invoked afterward. So as you might be wondering, you see in the PA1, you must have some sort of main method to run your code. Otherwise, it's just a method, and it's created, but it's not run. So after the some code is being compiled from the .java into the .java class binary file, the main method is the first to run. Yeah, any question for the first one rather than that question? I'm sorry. And the second practice is the JUnit test. So after PA1, we asked you have to do a JUnit test for your own program. We're not providing example tests anymore. So PA1, you might submit your code to the Gradescope, and it will like a sample test case pop out. That's the thing for PA1. It won't happen for later PA. So you might test your implementation in the main method, right? It's cumbersome. It's very tired, and it's prone to human error. So there must be some way that we could test our code with more efficiency and without making our mistakes, human mistakes. So Java has several unit test packages that allows you to test your code in a separate file, or use JD dog test. I just found that out yesterday. I don't know what that is. That's some dog test that you could write tests in your same file, but we're not going to teach that in the class. So in this class, we're teaching the Java package called JUnit4. So if you want to learn more about unit testing, there's a link to Introduction to JUnit4. So unlike dog testing, let me do this. So unlike dog testing in Python, JUnit4 requires an explicit assertion statement for each condition. So you need to assert equals every single stuff that you are going to test. It's unlike Python, where you could, remember in dog test, you have 3 curly, like a smaller signs, and like some function, some input, and here is the place that you put your expected output, right? So in Java, you need to do assertion explicitly, assert equals, and there's an 2 argument, which I will cover that later. So you should also, there's a lot of assertion method that is available to you. So there's another trick. IntelliJ is intelligent. You can create a JUnit test template using IntelliJ. So if you could, download this PDF. There's here's the list of steps and I will go through that using a demo, but I'm not able to share in those two screens. So, yeah. So, okay, the first step is, so here's my IntelliJ. Yeah. No. It is one single thing. So it's assert equals, it's like a function. And there's nothing between it.
What's the difference though? Assert equals versus just assert, and then two things with like two equal signs.
Java does not have that. Java does not have assert something equal.
I use it though.
But that in JUnit test?
Yeah. So I put like assert and then like stack dot pop something equals equal. Value.
I never used that before. I'm sorry, I don't know that. I need to look in that. Yeah, that's not the way we did it during I will show you how to using the standard JUnit way. Any other question? Yeah. Any comments on my replies? Okay. Give me 1 second. Okay, so here is our Java file. Can you see it? It's dark. You can see it now. So the first step is right-click the class name in the Java class you want to test. So here, if you put your cursor here, right-click. And the second step is there is a generate ... option for you. So if you click generate option, it prompts up there's another like generate drop-down that for you like what you want to generate. There's constructor to string override method test and copyright. For this purposes, we want to generate a test. So it prompts up like a conversation windows that you could specify what we want to generate. So for this class, please use the JUnit4 class. Otherwise, you will mess things up on our Grayscale side. So JUnit4, make sure you collect the JUnit4. And the class name. Usually on the write-up, we specify like what tester code needs to have a specific name on it. So sometimes it's called test, sometimes it's called tester. Just be sure you have the same name. And click OK to create another test class. So here, right now, we create another class called Programming Challenge Test. But you see there's something red happening here. So something is red in the Java IntelliJ means that Java is not, IntelliJ is not happy with what you write here. So it will happen all the time. So if you move your cursor to the JUnit test, it says cannot resolve symbol JUnit because you have not imported into the structure of your directory or the project. So there's an option that you could use to fix, which is add JUnit4 to the class path. And click that. And click OK. And right now, it adds the JUnit module into your class path. So be sure to do that step. Otherwise, your JUnit file won't run because the IntelliJ does not know what org.junit is. And I saw some student like asking Piazza post that they have a compilation error in the Grayscale. Be sure to import this JUnit, but not the other API JUnit. There's a lot of JUnit. So be sure to have that JUnit assert import statement. Yeah, that's the way how to create a JUnit tester file. Any question? Okay, I just went through all these steps from A to E. You could always refer back to this recording or the thing, the 4-step list on the PDF. So if you have any more questions, post the Piazza. Okay, so you might also find several tags useful when writing JUnit test, right? You have to, so JUnit test is like a standard Java file, but with a tag in it. We have 3 tags that we use the most. The first one is before, second one is after, third one is test. Like during the execution of a single JUnit test file, what does before do? Anyone knows before?
It runs whatever code is in the before it does every single test.
Yeah. And then after? Yeah. What test? Yeah. So before is the thing that you would likely to set up your test. Like sometimes it's useful for you to initiate some instance variables that is going to test throughout the PAs, throughout the Java scripts, Java file, sorry. And before is run every single time within the test. So what does that mean? Is every single test with has a before and has an after. So if I have 2 tests, test test1 and test2, and there are 2 methods. And what is the sequence of running these 2? I guess I will do that. That's the second question. So what is the execution sequence of the following JUnit file? Assume it executes each test in this sequence of test 1, test 2, and test 3. So here is the JUnit test file. I have an example here. And pay attention that I have a string as an instance variable here. You have to have that. Anyone know why I need to have this line? Yeah, correct. The scope. So I have 3 test files. I have one before. We usually call the before as setup, because this method usually set up for the test that comes later. I have 3 tests: test 1, test 2, and test 3. And after. And the name of the after is usually called teardown. So you clear what's inside. Yeah. So before is run every single time before the test, right? And I want to save something from the before, from here. I want this string, hey, to be usable in the test later on, right? So if I do this, if I do a string, hey, I'm creating a local variable, right? It's only accessible within the setup method. It won't be accessible in the test method. You will find something like, what is string? Java does not know. So you want to declare it before every single test. You want to declare in the outer scope, so that to make this instance variable accessible for every single method. Yeah. So if I do that, the test2, test equal hey string, it will work. Yeah. I think so. Yeah. It just you could add more. But I think the scope is not still within the setup. even though it's a static variable. Mm-hmm. Yeah, it can be anything. Yeah, so the reason why this hey hey is a string, because first of all, hey hey is a string, and the second, the string, this is a demo, so you could also do like integer, like some int, and like do int so equals to 3, and then you could use that in the. Mm-hmm. You mean this one? So that is, so I omit the whole class thing, right? This is like a demo, like class demo, like there's a query space and there's a none. So this is within one class. And string str semicolon. Yeah. Yeah, initialize a variable called string and tell the IntelliJ that, okay, str is a string. Yeah. Any other question? Cool. So, okay, I guess this is more clear. And assume that we will run the test 1 first and test 2 second and test 3 the third. What should be the sequence of execution? Like, which part of this program should run first? Yeah, the before. And then? Test 1. And then? Yeah, the after. And then? So I hear two voices. Someone says test 2 and someone said before. So raise your hand if you think it's the before. Yeah. Why? Yeah. So you should have the before is run every single time with the test. So after I finish test 1, before is run again. So you cannot assume that, okay, the thing is carried on. So before initialize the string to hey, hey every single time. It runs the test. And then what's next? After we run the before for the test. Okay. Yeah, I guess. I'm not sure. I'm sorry. And I think you could declare it outside. Yeah, and that's definitely doable. But the reason why we want to have it in the setup is sometimes you have more complicated interaction between classes. So it might be reasonable if you want to set in the setup because it makes sense a little bit. Yeah. So after before for the test 2, so after the before run the second time, what should be the run? What should be? Yeah, test 2. And then after. And the third time, it's the same, right? We run before the third time, and then do test 3, and then tear down. So I'm using an arrow to show the sequence of the running. So you see that we run before 3 times, we run after 3 times. So yeah, use this structure to clean up your JUnit file. The reason why we want to use before is because test 1, test 2, test 3, they all use the string, right? They all use this string. So it is reasonable that you initialize it every single time before this to make your test file more readable. And so this is based on the assumption that test is run in this sequence, test 1, test 2, test 3. It could be random, but it's just for the demo purposes. The important thing is the run, each test has a pair before and after. Yeah. I don't think that's allowed. You could only have one before and one after. Yeah. You could miss. The sequence does not matter. Yeah. Any question? No? Pardon? Void method? So each test should be returned void. It does not return anything. So it's just doing assert equals inside each test. So if str is equal to hey, and you pass the assert silently. And if it does not equals to hey, this assert equal statement fails, and it will tell you that it fails. So every single test method should be a void, should be return type void. The original function? So I guess you're referring to PA2, right? I guess you are referring to some method in PA2. Yes. Yeah. So you cannot directly test the result of the push because it does not return anything, right? But you should test. Okay, what is the size of the array right now, or the linked list, whatever. So you should test. Is it making an effect? Is it changing something? So you could indirectly test your push method. Yeah. Any other questions? Okay, the third part, IntelliJ debugger demo. So I'm repeating myself a lot of times. IntelliJ is intelligent. It provides several useful tips for you to debug your code. And once again, this is very useful trick when we are creating more, when we are creating PA with higher complexities. So be sure to learn that trick, and it will be coming handy later on in the PAs. So I will not sharing this anymore and do the demos. So if you have it in your local site, would be appreciated because, yeah. Oh, I'm not screen sharing these steps anymore because I need to do the demo. But you could always download the PDF to see the instructions step by step. So the first part is create a breakpoint. So okay, after you're done with PA1, this is the solution of PA1. So, okay. So for example, I want to test the reverse even number, whether it's working as I expected. So you could, so see my cursor? There's line like 11, 12, 13, 14, 15. There's a little area here that you could click. So for example, if I click on the 13th line, there's a red little dot that appears, right? And it highlights, I know it's hard to see, but it highlights this line for you. So it's saying that, okay, IntelliJ, Java is like a runner, right? It's run every single time, right? Every single line, run your code. And this looks like a stop sign, right? So it's like run, and see the stop sign, and it stops for you. And then it allows you to see what's inside every single variable. So let's actually do that. So test public void test1. Okay, it says test is not defined, so you could import it. It's programming challenge dot reverse. Okay, here's one very simple test. I'm not asserting anything, but I'm just creating a new integer array and then pass it into the reverse even number method, right? Everyone with me? Yeah. So you might see there's like a play button here, right? And if you click it, there's several options. I know it's small. The first one is set run test 1. And if you do that, it runs the test for you, but it's just a plain test. It doesn't do anything. But Java debugger run in a special mode. So if you click this, the second option is debug test 1 method. So you could imagine the first run test 1 method is running without a stop sign, just executing everything from the start to the end. And in the debug mode, the Java looks for the stop sign. And whenever it hits the line I mark using the breakpoint, the red line, it stops for me. So let's do that. Debug test 1. And it jumped to, so it's run line by line, and it hits this point, and okay, I stop. I would give the control to you. Yeah. And any question upon this point? It does not visualize the process, but it shows you the variable. Let me make that bigger. Can you see it? No? I don't know how to make this bigger. Okay, give me 1 second. I have a thought. Is it better? Okay. So let me run that again. So okay, it stopped at this line, right? And it prompts you variables. That is still very small, but it says variables. And R, integer, 1, 2, 3, 4, 5, 6. You realize that, okay, that's the input that I'm putting. So that's good. So there's several options or manipulation that you could do for the debugger. The first one is step over. You see there's a debugger console, and this is step over. This one. So step over is telling the IntelliJ debugger to step over 1 step. So before it's running really quickly without telling you anything. But right now, okay, I hit a stop sign. Tell me when should I step next. And if I click step next, the line goes down from the 13th line to 15th line, right? The 14th line is not executed, but because that's a comment. There's nothing to be executed. So the 13th line is executed. What did I do in 13th line? What does this line do? Yeah. I initialize an empty array with the length of the array, ARR, right? So, and I call it even index. And that is effective because I see a variable called even index equal to 0, 0, 0, 0, 0. Yeah. And the highlighted step is the step that IntelliJ is going to execute it next. It haven't been executed. So it's going to be executed. Yeah. So if I click next, an integer variable called number of even should be created, right? Yeah, you see it pops up here. Any question upon this one? So it is a very powerful tool that allows you to inspect, like during the execution, what is the variable of this and this. And later down, when we go to a higher, like more complex PAs, it will be super helpful. And the step over is the thing, is the button that we use the most often. And you could always step over and visualize like the execution process and to see the variables in the little box. And array, because that's a packed variable, right? Array is a multiple integers. So you could make this, you could expand this to see every single element in the index. And you could even move your cursor to one variable in your code, and it will tell you, okay, number of even right now is equal to 0. So it helps you to understand your program and understand what it really do, like how it was execution, what the execution said. So any question upon this one? Show what number? Oh, you just move to here and it shows the 0. No. You just move here. And it tells you the even index, what's in that even index. And there's another useful trick. So, okay, I want to know array ARR modulo 2, whether that is equal to 0. That's the condition, right? That is the expression that I can evaluate. So down the variable, here's a little plus sign. It says a new match, a new watch. So here are variables that you're watching, you're inspecting, right? You could create a new one. And it's very versatile. You could create anything you want to express. So let's say I want to look into what is the current value of the array I modulo 2 equal to 0. I could do copy and then paste. It will send is equal to 2. Does that make sense? This is index, this is value. You mean this? So this is an expression, right? This is an expression. And this expression during this execution is true. I don't know. Let's look into it. I right now is 1. It's checking the value in the array, in the AR.
So is that 2 right now?
Yeah, it's 2. 2 is an even number. Make sense? This or the whole window? This? There's a little sign to expand the array. Yeah. Yeah, you could expand the things, right? Yeah. What? This one? Oh, so right now, so I'm looking at value of I. I'm not typing I equals to 1. I'm asking the IntelliJ, like, what is the value of I? And it tells me I equals to 1. Yeah. It tells the values. Yeah. Yeah. Pardon? Yeah. So if I step over one more index, it's false again, right? Yeah. Yeah. Any question? Any other question? Yeah, this is one way that you could use the IntelliJ debugger. And sometimes you might wonder, okay, I have a long program, and I use this like function multiple times, right? How can I tell the IntelliJ to stop exactly when I want it to stop? So there's ways to do that, because, for example, if I want to stop at the for loop, if I want to stop every single time when the index is like odd number, this is like completely random. I'm just making it up. So I want to stop when the I is like 1, 3, and 5. So here's a condition, right? So I could right-click it. Right-click the little stop sign. Right-click it. It prompts a window that allows you to input and conditions. So this allows you to add condition to the stop sign. So it's like, okay, I'm like running. I hit the stop sign. I evaluate the condition. If it is true, I stop. If it is false, I just continue running. Yeah, the condition is the if statement. The condition is the if statement. Well, it's debug, right? It helps you to debug. It does not do anything to your code. So it's like it's specifying the stop sign, condition of the stop sign. So I can do I modulo 2 not equals to 0. So there's not if statement in here. This is just a condition. Condition is only true and false, right? You're just passing a true and false condition here. And if I click down, you see there's like a question mark down the stop sign. It tells you, okay, this is a conditional stop sign. And if I run the program again, okay, I have an error. The reason why I have an error is during the execution of this point, the value of I is not initialized because it's initialized during the for loop, right? Anyway, that's my fault. I should do that here. So if I rerun, you see it skips the index 0 already. It already jumped to the the first index, the 0 and 1. And if I step over again, it will run like just as because you have already stopped, right? It will also show the second index, the third index. So it's just the conditions for the initial stop. But when you after it stop, it runs by your mark, on your mark. Yeah. And I can even do something crazy here. I equals to 4. I just want to check when the for loop when the I equals to 4. And I can do that and just rerun the code. You see the I right now is 4. Yeah. Any question? So be creative when using this tool. So you want to check like the condition. You want to check after, like, if I push something into my stack, for example, I could tell the stop sign to be stop. Like, if I push 1 into the stack, I can tell the stop sign when the pushed thing is 1 and stop it for me. Yeah. Any question? Any concerns, thoughts? Yeah, sure. I'm not sure I will have an answer though, but.
How do we check, like if you create an object, so let's say you make a stack, how do we check, like what assert would we use to check the stack?
What do you want to check?
That it's made. Like, don't we have to test if we made the object?
Well, that is a good question, but I don't think you should check it because after the line, it's pretty much promised that it will be created. So you should. So I guess you're asking the in stack, right? The constructor of in stack. So the in stack have 3 constructor with 3 different parameters. So you should check the object, the sum, like the features inside the object, the instance variable inside the object, to check whether that makes sense. Like the capacity, whether it's the initial capacity I specify. Yeah. So it's like not directly checking on it, but indirectly checking on this. Yeah. Did that make sense? I think I'll make a Piazza answer to that, but if you could see. But the real quick one, there's 2 ways to test it. The first way is to, so as a test, there's expected. You could specify expected, for example, it throws illegal argument exception. Another trick, illegal argument exception, just type IAE. It will pop up, IAE. The third one, dot class. Yeah, and in this way, you're telling the JUnit that, okay, this method must throw this exception. It will fail if it does not throw this exception. So let's run it, because we know that this won't throw any exception, right? And it will fail because it says assertion error, expected exception, illegal argument exception is not thrown. Yeah, that's the first way you could test your code, the exception part. The second way you could refer to the Piazza one, using try-catch. Yeah. I guess today's discussion is finished, and if you have questions, feel free to stop by. Yeah.
这种我现在学一下这个之后，所以我 indirectly check， 比如 check capacity 或者 check load 来 check 我这个什么创造出来是吗？对，那我 check 9个是吗？你有3个 constructor， 说每一个得 check， 还是我只 check 这一个 the main one 就行，因为他们其他都是 inherited。
你可以，但是你要